Hello everyone, welcome to the studio of TTI Takatpur. I am Marndi and my trade is fitter and my topic is heat treatment. So guys, today we are living in a world where technology is the vital force. Everywhere we are using machines instead of manual power, and machine has also made our work more easier, more faster and more efficient. And after the industrial revolutions, now we are using metals and we are composing metals with different percentages and we are making the parts of the machines. And for that purpose, raw material or the ore of a metal is being extracted and it is composed with other metal, and then only we are able to make that part. So in order to improve the various properties of a metal, because sometimes we want in different application we are using different kind of metal, and in different applications we are having the variety behaviors of grain, or we are having the variety properties of metal which will satisfy in that particular field. So sometimes we want the metal to be drawn into wire, sometimes we want the metal to be drawn into sheet, or sometimes we want the some kind of application where the core is to be hardened or the soft is or the case is to be hardened. So all these thing or all in these various applications, the metal which is being used or the various phases of steel or various phases of iron is only possible with the help of heat treatment method. So let me introduce with the topic heat treatment method. So heat treatment is a process of heating and cooling of a substance to a desired rate or at a definite temperature through the modifications of their crystalline form. So this is the heat treatment method. For a complete heat treatment method, we require three important parameters, and those are the temperature, the time and the rate of cooling. Temperature, which is a very important parameter, because it is also required. From the name itself we are knowing that heat is any metal which is being heat treated is heated first. So temperature is most important. Then after, length of time. Length of time or the metal which is kept at a definite temperature is called soaking period. So it will also can be called as length of time. And third one is our rate of cooling. So on rate of cooling is also very important, because due to change in the rate of cooling, we can get various type of metal or we can get various phases of metal. So these three important parameters are mostly required for a complete heat treatment method. So why we are doing the heat treatment method? So here you can see in this slide we are having a various purpose of heat treatment method. So for this purpose, or to use a metal in a particular field or to in a particular applications, we are have the same metal is provided with the various kind of phases which is having various compositions which will show various grain size in order, which will show that it is having various behavior of the grain which will bring various properties of a metal. So here we can see that we are having purpose of heat treatment. So why we are doing heat treatment? First purpose is it will improve the physical property and mechanical properties of a metal to improve the hardness and strength. So hardness is also hardness and strength is also a mechanical properties of a metal. Second, to improve the wear and resistance. So wear and resistance is also a properties of mechanical properties. It is the ability of a metal to resist the material loss. Where the material, wherever there is a mechanical actions or wherever there is a any kind of machine is going on, then definitely there is a mechanical action is also going on, and during mechanical action the loss of material is will become more. So in order to reduce that loss of metal, another property is added to the metal, that is called our wear and resistance. So the wear and resistance property will also get increased. And third is to resoften the metal. So one metal is used again and again in different applications. So how it is used? If it is used in one applications, it can only be used in another applications if it is heat treated. So heat treated, if it is heat treated, that means heat treatment method is done. So if again we will do heat treatment method, there will be change in the crystal, there will be change in the properties. So third is to refine the grain size. So heat treated is done, that means there will be change in the grain and there will be change in the properties and there will be change in the phase of the metal. And this next is to produce the special microstructure grain. So after the, in some phases, so with the increase of the carbon content and with the increase in the temperature, the grain size will also get changes. So though sometimes at some certain temperature and after the after the additions of the certain percentage of carbon, a phase will come where in that phase microstructure grain is also required. So after, by doing the heat treatment method, we can get that microstructure grain size. And last is to improve the fatigue and corrosion resistance. It is the same. So the removal, the loss of material will also get reduced. So these are the most basic important purpose of heat treatment method, that why we are doing the heat treatment method. Heat treatment method is being done to use that metal in different applications, and how we will use that metal by composing it with the various other element, with various other metal, and we will heat treat it, and then again we will cool it, then again we will use it different applications. So this is, here you can see that here I'm showing you typical heat treatment cycle. So with this cycle I will tell you how the heat treatment is being done. So here you can see that here there is a graphical structure. This line is our x-axis and this line is our y-axis. This is y-axis and this is x-axis. X-axis represent time and y-axis is our temperature. So this is a temperature versus time diagram, where with this temperature versus time graphical diagram I can show you that how heat treatment is done. So with the increase of that this line is the heating line. With the increase of the time and with the increase of the temperature, heat treatment is done. So by heating process is done, then after heating process is done, temperature is kept constant and only time is increased. So this period is called our soaking period. This period is called our heating period. This period is called our soaking period. Soaking periods means in this period metal is kept constant or metal is held at that temperature for some time. That some time it can be of it may kept there for 6 hours or it may be kept there for 7 hours. There is no particular duration for any kind of metal. Time durations will be differ for according to the applications. So after the soaking period is done, then there will be decline in the again temperature. So this declining temperature is called our cooling rate. This is our cooling rate, and or we can call this as cooling period. And cooling period will be different for different kind of metal. And depending on this cooling period, our heat treatment is classified into 4 different methods depending on the cooling period. So cooling can be done at a very slow rate, cooling can be done at a room temperature, cooling can be done at a furnace temperature, or cooling can be done at a water temperature, or any medium we can use it. So depending on that cooling period, our heat treatment method is classified into 4 different types. So these are the 4 different methods of heat treatment. So first is our annealing method, then come our normalizing method, then hardening method, then tempering method. All the heat treatment process carry out the same process, that is the heating of a metal, holding in that temperature and then cooling it. But depending on that cooling rate, we are having 4 different type of heat treatment method. Annealing method. Annealing. So here also, here what we have to do, this process also carries out heating plus holding plus cooling. So here I have included all the basic parameters of a heat treatment method, that is temperature, time and cooling rate. With this temperature, time and cooling rate, we have completed the annealing heat treatment method. So, but only the difference is how we will differ all these four heat treatment method. That will be depending on the cooling rate. So, how here the cooling rate is done? Cooling rate will be done at a very slow rate. Only the cooling rate is done at a slow rate. Slow rate means we will, after the metal is held in that temperature, we will cool it in a furnace. So the furnace will also carry that amount of temperature for that durations. So after it will take 6 hours or 7 hours or 12 hours or maybe 24 hours. So in that temperature only, holding in that temperature only, the grain size will get cooled, and all the layer by layer will get cooled, and in that layer the acquired behavior or the acquired properties, whatever the material is acquiring, that product will be called as metal which is produced from the heat treatment. That is annealing heat treatment. And the main purpose of annealing heat treatment is to get soft material. Main purpose of annealing heat treatment method is to get the soft material, which in order will produce a ductility property. So ductility property is produced by annealing heat treatment method. Second is our normalizing heat treatment method. So normalizing, here is also our same process. First is heating, then holding, then cooling. And but here the difference will be in the cooling rate. First one is cooled with the help of at a very slow rate. Then second one will be cooled with the help of air cooling. Air cooling means we will use any kind of device that so for example fan or blower or any kind of thing that will give a power source air cooling. So with that cooling, whatever the metal is being produced, that metal will be called as metal of normalizing heat treatment method. And here also the behavior will also change, the grain size will also get changed, and composition will also get changed, and whatever the annealing material is producing soft material, this material will produce a little more harder than the annealing, but not as much as harder than the hardening process. Whatever the material hardness, that material will be containing the property harder than the annealing but softer than the hardening process. So it will basically, it will have strength, machinability property, wear to resistance, wear to corrosion. These other properties are also there. So after normalizing, hardening method. So hardening method is also followed by heating process, holding process, and then cooling process. But here the only differ will be there. Here rapid cooling is carried out. In case of rapid cooling, we will use any kind of medium, and that process, the process of using any kind of medium to cool a substance is called quenching process. So in total, we will call this process as a quenching process or quenching method. So in quenching method, what happened? After holding the metal at a definite temperature, we will cool it at a very rapid rate. So we will use a bucket of water, or we will use anything that is in a molten state. So after dipping it in that molten state, then we will get out the metal. So whatever the properties it is acquiring, that metal can be called as the metal of hardening heat treatment method. And here there is also change in the behavior of the grain, there is also change in the properties of the metal, and the properties metal will get changed to, it will produce hardness or brittle metal. It will produce hardness and brittle metal. So if a metal is kept in a quenching process, or if a metal is kept in a quenching medium for more than 6 to 7 hours or more than 12 hours, then the whole metal will get brittled. So if we are using that brittle metal for a particular applications, then that metal may get cracked due to some load. So in order to avoid that crack, or in order to avoid that much of hardness, then we are doing the tempering method. So tempering method is always done on the hardening metal. Whatever metal that has been already that has been treated with the hardening heat treatment method, that metal, if it has gained the brittleness more, if it cannot be used in any kind of particular applications, because due to its brittleness, and that metal can be treated that metal can be used for the tempering heat treatment method. So tempering heat treatment method is a process of heating the hardened steel. So tempering is a heat treatment method of heating the hardened steel, then again cooling it below the lower critical temperature. Every process contains a definite temperature. Everywhere the metal is to be heated up to the lower critical temperature, and it has to be ended the upper critical temperature. So everything has a definite temperature, and the holding temperature is also a definite, and after cooling rate is different for everything. Process and normalizing process are differ from each other. So first point is, it is a process of heating to a predetermined temperature, holding at that temperature and cooling at a slow rate. So first difference is at the cooling rate. Annealing is cooled at a slow rate and normalizing is cooled at a air rate, air cooling. And after that, properties of the metal will also change. Here the properties of the metal is to get softer. Here the properties of the metal is to get little hard, not more than that hardenability, but little hard more than this. And if a metal is soft, then it contains the ductility property. So if a metal is containing a ductility property, that means it has the ability that it can be drawn into a thin wire. So that is the properties of a ductility. So here the ductility property is improved, here the strength is improved. Here the grain size is caused, and after the grain size, here we can get that grain size of very fine. So grain size always changes due to rise in temperature. And the time where the grain size start changing, that particular temperature is called the lower critical temperature. And where the grain size doesn't change, or where the change become end, that point is called our upper critical temperature. So this is the only difference between annealing and normalizing. So hardening, I have told you that hardening is a process. Process is almost same, but the cooling process is different. Here we are using a quenching medium, or we are using a molten state to cool the metal. So if we are using molten state to cool the metal, then definitely there will be a sudden change in the behavior of the grain. So which instead will change the properties of a metal. This is also heat tempering, and here is the difference between hardening and tempering. So hardening, it is a process of rapid cooling, but tempering, it is a process of heating the hardening metal. This is the only difference between these two. Next, here the pearlitic grain size will change to martensitic grain, and here ferrite and cementite will change to austenite grain structure. All these pearlitic grain size, martensitic grain size, ferrite grain size and cementite grain size, all these phases are nothing but a phase of iron. All these things are the phase of iron. Means whenever we will keep a solid iron in a definite temperature, so due to the change in temperature and due to the additions of carbon content, iron will have different phases. So that different phases we will get through the heat treatment method. So here we are getting martensitic grain, and here we are getting austenitic grain size. So austenitic, here the grain size will also be different, and due to the change in phase the name is also different, but both are the iron. And here the temperature is little decreased, here the temperature is increased but below lower critical temperature. Here the properties which is main, we know that the heat treatment is done to change the properties of a metal, and due to that change in properties of the metal, that metal will be used in different applications. So here due to hardening we can get hardness property, and due to tempering we will get toughness property. Toughness is the another mechanical properties, and toughness is such kind of property in which a metal will absorb the energy if it is treated under external load. And lastly, it will increase the resistance to deformations, and this will remove the excessive hardness, because this tempering is done on the hardening metal. So these are the only difference between hardening and tempering. So that's all. I hope you have all understood about you have cleared your doubts about the annealing, normalizing, hardening and tempering. And thank you.